Hello, I'm Eric Brunn, and I'm with Non-Random Team 10, otherwise known as the Tiny Task Terminators, and this is the Sweep Swoop. So the Sweep Swoop is a piloted drone that's made for dusting high and hard to reach places like the top of a ceiling fan or a dresser or something super high. So we'll go ahead and go over the wiring diagram. So we have a few critical features. One is the optical avoidance distance sensor. So this is basically an ultrasonic distance sensor that will turn the drone into a hover speed when it gets too close to an object. We have 4 flight motors that are all individually wired, and the reason why they're individually wired is because with a quadcopter flight, left, right, up, and down, as well as back and forth, they all need to be individually controlled because of the combination of motors changes every time. So because of that, we have a 5th motor, a brush roll motor. This would be tied to the microfiber brush roll that would be dusting the actual objects that you're targeting. And that had to be hardwired to just run constantly because I ran out of pins that weren't serial communication pins, and they wouldn't run real well with my serial print commands. So I also have an IR control, and this will be the interface that the pilot will use to fly the drone. So let's go ahead and run through the code real quick. So we'll go ahead and start the sensor. Right away, you see the serial monitor is giving us our distances. You can see that's called out here as a safety distance, which I put at 20 centimeters. You'll see that throughout the code whenever this is referenced. So first off, I had to put interruption to the loop, and I had to do this because every time I did it in any other orientation, the delays were messing with my commands to the IR controller. So this is what worked best for me to be able to do that. So we'll go into the IR commands. So IR commands, if you watch here, we'll give it a 0 command, which is a power on. So the value will be 0, even though the button is a power on command. So you'll see it pop up. It popped up real quick, and we go into a standby hover mode. Well, it's not really a hover mode, it's a spin up mode. So these rotors are basically giving you visual feedback that the drone is ready to get commands. It's not flying, but it's spinning up. So we also have 2 and 8 in a north and south orientation here, and that is to gain and decrease altitude. So if we go ahead and hit the 2, you'll see the serial monitor to input that, and we're spinning up to full speed. If we hit 8, you'll see the serial monitor input that, and we'll go down to half speed to decrease altitude. Same thing for yaw left and right. We have the same kind of commands, but in this one and this one. So that's given us half speed on this side to dive to the left and full speed on this side. And then the opposite is true when we hit 6, and that's giving you left and right commands. So finally, we have forward and back commands, which are done with these buttons, which will do these 2 types of dive and reverse. So you can see these are now ramped up and these are lower, and the opposite is true when you hit the back command. So let's go ahead and say that we get too close to an object, and you'll see that these RPMs are moving. And once we get within 20 centimeters of an object, they all ramp down to a hover speed. This will stop the flight of the sweep swoop, avoiding any collision with any fragile objects or even crashing the machine itself. So once we go back up past 20, we are able to give the machine another command to ramp back up to speed. So that is the sweep swoop. We'll go through the whole code. That is the sweep swoop, and thank you for watching.